Good morning, student. I, VINITA MATHUR, Faculty of Electronics and Communication Department in Arya College of Engineering and IT. I am giving my lecture on microcontroller, which is being conducted in 4th semester EC branch. Today we are going to start Unit 4th as per syllabus. First topic is Introduction to RISC processor. Basically, there are two types of processor designed, CISC and RISC. CISC is known as complex instruction set computer, whereas RISC is known as reduced instruction set computer. Both are used as a processor. CISC processor, basically it is used in desktop and laptops. Complex instruction set processor or compiler was designed to make a single instruction for loading, storing and evaluating the operation. Let's say we take an example of multiplication command. We do the stuff like loading data, evaluating and storing the data. The approach of CISC processor is to minimize the number of instructions per program, but with the cost of increasing number of cycles per instruction. As the number of instructions are reduced but increase the number of cycles, hence the decoding of instruction become complex. Instructions are larger in size, which are not of one word size. Instruction may take more than one clock cycle to get executed, because of which complex instruction set require more time as compared to other processor. As from the flowchart of CISC processor, the machine instructions are divided into microcode, which is converted by macrocode conversion unit. Then these macrocodes are divided into micro instructions, and then these macro instructions are decoded and executed. This flowchart shows the 4 units which require 4 cycles, because of which the execution time of CISC is very high. Now, RISC architecture. This architecture is basically used in portable devices like mobiles, tablets, etc. The main idea behind to design this hardware is to use the instruction which is composed of few basic steps of loading, storing and executing, just like a command for loading, storing and executing. Here the instructions are simple, so it can be decoded easily. Here instructions come in one word size. There they come more than one word size. There we require number of clock cycles to execute one instruction. Here one instruction takes only one clock cycles, so the time requirement will be less as compared to CISC architecture. Pipelining, which is very important features in any architecture, is achieved, so that the speed of operation will also increase in RISC architecture. Now the flowchart of RISC architecture. Here the machine instructions are directly decoded and executed in instruction execution unit. So it requires less instructions as well as execution time is very less. As from the figure CISC architecture, this architecture requires minimum number of program and ignoring the number of cycle per instruction. As from the figure we can see that microprogram control unit sends the control unit and microprogram. These microprogram provides the instruction and data path, and then these instructions and data is saved in cache memory, and then it is provided to main memory. The process of data and instruction to fetch to the cache memory to the main memory is time consuming. So we can say that there is no pipelining, because of which it requires larger time. Now we see the RISC architecture. Here we use an hardware control unit. This unit provides data path as well as instruction path. Data path is fetched by data cache memory and instruction is cached by instruction cache memory, and both are provided directly to the main memory. In this processor we can see that the pipelining occur. Pipelining in terms of hardware unit provide instruction cache as well as it provide the data to data cache simultaneously. So the processing speed will be increased in this architecture. Characteristics of RISC architecture. Poor average through output near one instruction per cycle. Uniform instruction format using a single word with opcode in the same bit position for the simpler decoding. All general purpose registers can be used equally as source and destination in all the instruction. Simplifying the compiler designing. Simple addressing mode with the complex address performance by the instruction sequencing. Few data bytes in the hardware. Here the comparison between RISC and CISC is shown. CISC architecture require multiple clock cycle, whereas RISC architecture require single clock cycle. In CISC, any instruction may refer to memory, but in RISC only load and store refer to memory. In CISC there is no pipelining. In RISC there is pipelining, because of which the execution speed increases. In CISC the instruction interrupted by the microprograms. In RISC instruction are executed by the hardware. In CISC variable format of instruction because it doesn't line one word, whereas RISC instruction line one word only, so it has fixed format of instruction. In CISC many instructions and addressing modes are there. As variable format there will be many addressing modes. In RISC few instructions and modes. In CISC single register set is required, whereas in RISC multiple register set is